Okay, good morning everyone. Welcome back to my YouTube channel. It's again web saturation. And today again we continue with chemistry, but today we'll be looking at more concept, specifically at the Avogadro's constant, how to find the number of moles using the Avogadro's constant, and how to find the number of particles, molecules, and but before we go into the details, please subscribe, like the video, and also share the video to others so that we can be updated together and you become the first person to know that Webster has posted a new video on the YouTube channel. Okay, so we'll be looking at more concept, how to find the number of moles as well as how to find the number of particles in a given substance. So first of all, what is the mole? A mole is a unit of measurement used to express the amount of substances. So a mole is a unit of measurement used to express the amount of substances or the amount of materials in a substance. A mole is a unit of measurement which is used to express the amount of material in a substance. That is what is called the mole. So on this topic today, we just focus on the Avogadro's constant. Then the other day we look at more details and the more concept, how to find the mass and other things, volume, like the volume. Okay. So we specify the more concept to the Avogadro's constant for today. So Avogadro's constant or Avogadro's number. The Avogadro's number. So the Avogadro's number or constant is the number of particles present in one molecule of a substance. So is the number of molecules, could be molecules, you say particles if you may like. You can talk about atoms and ions. So the Avogadro's number is the number of molecules, particles, atoms, and ions present in one mole of a substance. Present in one mole of a substance. That is what is called the Avogadro's number. The Avogadro's number or constant is the number of particles, molecules, atoms, or ions present in one mole of a substance. Now, this number is constant, it does not change. The number is constant, it does not change. So if you want to replace the number with constant there. So the Avogadro's number, will be using the abbreviation Avg, then also number, that side, is equivalent to 6.022 times 10 to the power 23. The number is quite big, so in recording it, to make it easier, we use the standard form for us to make it easier. Because if I write the whole of this number, it's quite big to know. Okay, so the Avogadro's number is equivalent to 6.022 times 10 to the power 23. It's quite a big number, that one. Okay. Now, when using the Avogadro's number and we want to find the number of moles, the formula which is used is the number of moles is equals to the number of particles. If I've been given molecules, use the word molecules. If I've been given atoms, use the word atoms. If I've been given ions, use the word ions, over the Avogadro's number. Number of moles is equal to the number of particles or molecules or atoms or ions over the Avogadro's number. Now let us look at some couple of questions. We see how to use this formula and we work together. If you have a calculator, please put it near you because we So example 1. Examples. Example 1. How many atoms are in 0.5 moles of sodium? How many atoms are in 0.5 moles of sodium? How many atoms are in 0.5 moles of sodium? Sodium is a metal found in group 1 of the periodic table. Yeah. So how many atoms are in 0.5 moles of sodium? So in this question, we are not looking for the moles. The moles is already given. Now we want to find how many atoms are present in this sodium. So we use the same formula, of course, where we say moles is equals to, in this case we have atoms, so the number of atoms over the Avogadro's number. The number of atoms over the Avogadro's number. We want to know how many atoms are present in 0.5 moles of what? Of sodium. So where there are moles, we put the 0.5 moles because that's the number of moles there. So we have 0.5 moles is equals to the number of atoms, the one we don't have there. So atoms, which we don't have, over the Avogadro's number. The Avogadro's number is 6.022 times 10 to the power 23. You've got to know this number. You're not even in the question. You have to know that number to use it. So you really have to know what the value of the Avogadro's number. You can raise this one as a fraction by dividing with 1. Then we cross multiply because we want the number of atoms. So the number of atoms is equals to 0.5 times 6 times 6.022 there. Okay, this is just half. You're multiplying this by half, so okay, just reduce this by half. So that is 3.0. Again, reduce that one by half, 1. Then times 10 to the power 23. But if you're not sure, please use the calculator so that you can find the correct answer, so that you don't mess up. By just multiplying by half, 0.5 is half, so I'm just reducing this number by half. So yes, you can use the calculator. So we have about 3.011 times 10 to the power 23 atoms of sodium. Okay, let me say atoms in 0.5 moles of sodium. I'll just use the symbol. Okay, so that's how we go about it. Now we'll solve 2 more examples so that you can move together as you find questions in different books or papers, or probably the exam. So let's solve another questions where sometimes you can be asked to find the number of moles. Okay, so how many moles? That is example 2. How many moles are in 0.75 moles okay, it's supposed to be how many molecules? How many molecules, not moles? How many molecules are in 0.5 moles of water, which is H2O? Just use the symbols. How many molecules are in 0.75 moles of water? It is the same formula. It's quite easy, so I'll be much quicker on this part. So we have moles is equals to the number of molecules. Of course, I've been given molecules there. The number of molecules over the Avogadro's number. So the number of moles is given is 0.75 is equals to the number of molecules we don't have. The one we want over the Avogadro's constant 6.022 times 10 to the power 23. We raise this one as a fraction and we cross multiply. So we have the molecules is equals to 0.75 times the, okay, 0.75 times the Avogadro's constant. So to avoid mistake, you can use the brackets when multiplying that. Open the bracket, you say 6.022 times 10 to the power 23 and close the brackets. So we have 4.5165 times 10 to the power 23. If you want to leave that one correct to two significant figures, 1, 2, we have 4.5 times 10 to the power 23 molecules. Okay, so follow it closely so that you can solve more questions. Okay, now the other question involves us finding the number of molecules when you have been given, for example, the mass. So that is example 3 now, the last one, or we have been given the particle. So, okay, let me just erase this part. Okay, so how many molecules? That is example 3. How many molecules? How many molecules are found? How many molecules are found in 6.0 decimeter cubic of carbon dioxide? Carbon dioxide at RTP. RTP stands for room temperature and pressure. So how many molecules are found in 6.0 decimeter cubic of carbon dioxide? So here we don't have the number of moles. We have been given the volume of this carbon dioxide gas, CO2, like that. So how are we going to find the number of molecules? Of course, we know the formula is the same, where we have to use the number of moles is equals to the number of molecules over the Avogadro's number. But we don't have the number of moles and we don't have the molecules. So you have to start by finding the number of moles using the volume at RTP. You know, 1 mole of gases or 1 mole of a gas at RTP is equivalent to 24 decimeter cubic. So we have to use the standard volume of the gas at room temperature and pressure and the volume given in the question to find the number of moles. So the formula used here is moles is equals to volume of the gas over the molar volume. The standard volume is also called the molar volume. The volume given is 6.0 divided by the molar volume, which is 24. It is always the same 24, so you also got to know that one. You have to know that one. You have to know the standard volume. At RTP, we have RTP and STP. Okay. So we divide 6 divided by 24 to find the number of moles. So 6.0 divided by 24, we have 0.25. So moles is equals to 0.25 of carbon dioxide gas. Now that we have the number of moles, we can easily now find the number of molecules. So where there are moles, we'll be putting the number of moles one from calculating there. Are you following? Okay. Where there are moles, we put the 0.25, which is equals to molecules we don't have. One we want over the Avogadro's constant is still the same, 6.022 times 10 to the power 23. If you're able to get me that very clear, please comment in the section below, or you tell me to reduce the velocity, the speed at which I'm explaining this. We raise this one as a fraction by dividing with 1, then you cross multiply. Always start with the one you're looking for. Better that way. So 1 times the molecule, we have the same molecule. Molecule is equals to 0.25 times the Avogadro's constant. So the 0.25 times the, remember, open bracket, 6.022 times 10 to the power 23, and close the bracket. We have the number of molecules is 1.5055 times 10 to the power 23. If you are to leave that answer correct to two significant figures, 1, 2, we have molecules, but if you want to then leave it there, it's fine. Molecule is equals to 1.5, then the number there is less than 4, so we can't get 1 there. 5 times 10 to the power 23 molecules of carbon dioxide, right? That is CO2. Now, the last example, then I'll give you the questions. The last example, then I'll give you the questions to solve. The last example, I have to make sure that we solve as many questions as possible in different ways, so that whenever you find a question, you are able to find the answers. Okay, so the other question is that is 4. CH4, that's from organic methane, has 3.01 times 10 to the power 23 molecules, comma, calculate its number of moles. Calculate its number of moles. So here we have been given the number of molecules, so it's not the one we want. In this time, we want the number of moles. Of course, we are repeating the same formula. That's the only option we have in this case. So we have moles is equals to the molecules over the Avogadro's constant or number. We want the number of moles. We have been given the number of molecules, which is the 3.01 times 10 to the power 23. So we have to write it there. Moles is equals to 3.01 times 10 to the power 23 over the Avogadro's constant. Remember, 6.022 times 10 to the power 23. Okay, remember that one. I see the power 23. Then you divide this number into the number on top. Okay, if you have the idea in mathematics for indices, you just remove that, then divide this number there. Okay, you cancel those which are common and divide the remaining part, which is in 3.01 divided by 6.022. So we are getting number of moles is equals to 0.49983394 moles of CH4. So we have found the number of moles. We just leave correct to 2 or 1 significant figure. So we have the number of moles. If you want to leave it to 212, you get 1 there times the 10. You write a 0 there, the 1 goes there times the 5. So we have 0.5 moles of CH4 methane. Okay, I hope you have really enjoyed the lesson. If you have questions or more questions or more concepts, you can leave the comment down below, and please don't forget to subscribe. Let me give you questions. You may comment with the answers. I'll give you just 1 or 2 questions. Then you comment with answers in the comment section. Okay. So So I'll just give you one question. I'll just give you one question and leave the comment as the answer so that I see if you have followed closely, or please leave the question where it is not clear that I will be able to explain. Okay. So task for you. How many atoms are in 0.45 moles of water? Suppose you don't know, the formula for water is H2O. So please leave the answer and don't forget to subscribe. If you have liked the video, please share, like, and comment. I'll be reading your comments and also replying to your comments. So please do that, and you will become the people to be know or to be notified that there is a new video from Web Saturation. Okay, thank you and enjoy the rest of the day.